Hello, this is Costa. My teammate Sam and I have been working on this project, Portwarden, which will periodically back up your Bitwarden vault to Google Drive. And Bitwarden is an open source password manager. Most of its features are awesome, but its backup feature is not really that great. First, when creating backups, it only creates unencrypted CSV file, which is just insecure if you want to store it in anywhere. Second, it doesn't include attachments in the backup as well. That's why we created Portwarden to make backups better, also to demonstrate some interesting architectural design. If you pull the repository and if you Docker set up, you can just do what I did over here, Docker compose app-d. That's going to create, spin up the services required for our application. And you can use the Docker exec execution into one of our container and go run main.go. It'll spin up the server. And now, let me get something real quick. And now we're going to the front end. And we're going to hit get started. And when we do the get started, the user will look at the front end. The get started is requesting a login URL from the backend server. The backend server sends it back. And then the user goes to the Google authentication. And we have to select an account to log in. And once we do that, it gives a callback to the backend server. The backend server registers the user. As you can see, a user has been created in the Redis. Now the backend server sends a callback URL to the front end. And as you can see, the front end now has access to the access token and email and whether the user has set up the backup. So now that has been set, we'll enter our Bitwarden credential. This is a dummy account that I've created. And we just put those information in and add a passphrase and say set up automatic backup. And it's gonna tell me successfully set up backup. And if we take a look at the drive, we need to delete a bunch of things. And one of the files was basically created by that. And if you look at the Redis commander, it has created a delay task, which means it's going to do the periodic backup in every 60 seconds. It has an ETA for this task, and also the Bitwarden, the Portwarden, this particular Portwarden user has been updated. Specifically, this is the Bitwarden data.json is very important in terms of enabling us to do the actual backup. And within a minute, we'll be able to see another file. But before we get into that, just so you know, we can actually scale this up because we have the worker instances. One thing we could do is to use the compose with the K in the beginning that will convert a Docker compose file into Kubernetes definitions. Oh, there it goes. And after we do that, we can just apply. So real quick demo. If we do this, it's gonna create a bunch of files in this folder. We can always just cut it and paste it into the compose folder. And then we can do apply and it'll work. And this is our minikube. And as you can see, there are 2 worker instances. And we can get the URL for the scheduler, and well, oh, right. We can, first of all, cancel it, and second of all, change the Portwarden server URL to the Kubernetes scheduler URL. Also, I need to run the Docker compose down because the Google calls back into localhost, but the scheduling in the Kubernetes is not in the localhost. Now I need to do Docker compose down, which will clean up the service, just kind of delete them. But I do need the front end to be running, so okay, now it's working. So if we refresh it and just paste in, that's all right. If we just paste in the scheduler's URL and do get started, and this is gonna clearly show you how it's working, which is now, as you can see, it's going to the local host 5000, but now the backend server, the scheduler, is no longer in localhost 5000, but instead it's in this Kubernetes URL. And as a matter of fact, you can't really set this up in a Google Cloud as a callback URL because it's sort of considered as a public IP. And it creates a series of problems. And if you fake it with a fake domain in your host file, it also doesn't work. It, like I said, it introduces a series of problems. The simplest way is to just kind of hack it. Now, remember, if we look at the diagram, the Google authentication gives a callback to the backend server, and that's what we're seeing, the localhost 5000. And we're gonna replace it with the Kubernetes instance. Now it's calling back to the front end, which is 8000, and then with the access token and your email and whether you have set up. And now similarly, we can back up as we did before. Yeah, why don't we just do it? Another improvement I could definitely do would be to make this password no-show. Oh yeah, I haven't changed this to the Kubernetes IP. Alright, hopefully this will say successfully set up backups. And one thing about Kubernetes that's kind of awesome is that you can see the logs. So as you can see from here, the encrypt endpoint has been called, and as you can see from the worker instances, they're sort of handling the tasks separately, and this one is handling the newest one. And since the worker is decoupled from the scheduler, we can spin up as many replicas as we want for the worker, and that's gonna make it very scalable. Now, actually, I need to show you how to decrypt one file. I've created a demo file, and we're just gonna, you're gonna go to the release tab and just download an executable that's suitable to your platform. And then you're gonna do Portwarden passphrase and file name and decrypt. And it's gonna say decrypt successful. And then you can see, I'm gonna copy and paste this main.json, and this essentially contain, all of your credentials. As you can see, test username, blah blah blah. And if you have attachments, it's gonna be in this Portwarden backup folder. So yeah, that's gonna be it for the demo.